This is another example for finding the mean, range, variance, and standard deviation. Now this is for a population, and I'll tell you the difference between doing this for a population and a sample in just a minute. First thing you do is find the range, and my data points are actually here. And if you look at them, you'll see that the largest number is 47, the smallest number is 37, so the range, you just subtract the smallest one from the largest, the range is 10. Then you'll find the mean, and the mean for this is going to be 415. You add your numbers up, and these numbers add up to 415 divided by 10, because there are 10 entries, and you'll get 41.5 for mu. Now when we're talking about mu instead of x bar, you know that you're talking about a population. If I was talking about a sample, I would call it x bar. So what you're going to do now is you're going to take each one of these entries and subtract 41.5 from it, and this one becomes negative 0.05. Well, if you multiply negative 0.5 times negative 0.5, that's going to give you positive 0.25. You do the same thing with the 38, and you also get a negative number when you subtract the mean, and you get, when you square that negative number, you get a positive 12.25. Then you take the next number, 39, and subtract the mean from it. You get a negative number. You square it, it becomes a positive 6.25. Here you finally get a positive number. You have 45 minus 41.5, and you get 3.5, and when you square that, you're going to get 12.25. And you just move down each one of these, subtracted the mean. If I've already subtracted one of them, there's no need to do it again. I can just put what the difference is and then put what the squared answer is. So anyway, you work down all 10 of these numbers till you get each one of them done. The deviation tells how far this number is from the mean, so that's why you're subtracting the mean from it to see if it's below the mean, and that means it's negative, or is it above the mean, that would be positive. So I'll subtract all of those, I'll square all of the answers, and then once I'm finished, I'll add the two columns up, and you'll see that the deviation always turns out to be 0. Sometimes when we have rounding, it might be a little bit bigger or smaller than 0, but it's almost right on 0 every time. And what you'll do then is you'll add this column up, the column of the squares, and this means sum of the squares is equal to 88.5. Now, because this is a population, I have 10 entries, and notice I have a capital N here. That means it's a population. Population is always represented by capital numbers. And so the variance here would be 88.5, which you get from this sum of the squares, divided by the total number of entries, which is 9. Now, if I was doing a sample standard deviation, I would divide by 9, not 10, and I said 9 a few minutes ago because I was thinking about sample. But this is a population, so I'm going to divide 88.5 by 10. If it was a sample, I would divide 88.5 by 9. So, and the population deviation is always smaller than the standard deviation, is always smaller than the sample standard deviation because you divide by a larger number. So here my population variance is 8.85. And to get the standard deviation, all I have to do is take the square root of that 8.85, and you get 2.97. And that's a rounded number, so that's an approximation. But that's how you find variance and standard deviation, range, and you needed the mean to be able to do all of these. That's why you need to find the mean. This is to show you how to find the range, mean, variance, and standard deviation for the following data. And you'll see there that you have 9, 5, 9, 10, 11, 12, 7, 8, and 12. And it doesn't matter, you don't have to put them in order, that's fine the way they are. And what we want to do here is we're going to find the range first. That's the largest number minus the smallest number. The range is 7. The mean, you're going to add them up and divide by 10, and you're going to get that the mean is 9. Now, to get started with the standard deviation, what you do is this number is the first number that's listed. So that's 9, and you subtract the mean from it, and that's going to give you 0, and then you square that number and you get 0 for that one. For the next one, you're going to take the second number minus the mean, and that gives you -4. Well, -4 times -4 is equal to positive 16. So that number is going to be 16. Then again, here's 9, so the deviation is 0, and the square is also 0. Then you're going to have 10 minus the mean, which is 9, and that gives you 1, and 1 squared is 1. And you move down each number doing that. 11 minus 9 gives you 2, 2 squared is 4. 12 minus 9 is 3, 3 squared is 9. 7 minus 9 is -2, and -2 times -2 is 4. Here again you get -2 for the deviation, and the square is 4. Here 8 minus 9 gives you -1, and -1 squared is +1. And here again is 12. Your deviation is 3, and your square is 9. So when you add your deviations, this number should be very, very close to 0. And that's why you have to have standard deviation, is because the deviation always turns out to be very close to 0 and doesn't really do you any good. So then you're going to add these numbers, and you're going to get a total of 48. Now, if you're doing a population standard deviation, you take that 48 and you divide by 10, because there were 10 values that we were looking at. If you're doing a sample standard deviation, you take that 48 and you divide it by n minus 1, which would be 9. The sample is always divided by n minus 1, and the population is always divided by n. And this really should be a capital N here, not a small letter. Because population always deals with your capital letters. So now I'm ready to find the variance and the standard deviation. So for the population, if I'm getting the variance, I'll say 48 divided by 10, and that gives me 4.8 as my variance. And then I take the square root of the variance, and this is your standard deviation, 2.19. Well, if you're in a calculator, it will have this symbol here, which is theta, and it's going to be equal to 2.19, and approximately equal to that. And then if you're doing a sample, you divide 48 by 9, which gives you 5.33 as your variance, and your standard deviation is 5.33, the square root of that, and that would be 2.31.